Rank FAQs with cosine similarity in Python. By the end, you will build a tiny FAQ search that ranks answers by relevance. Inspect how cosine similarity scores short queries and add 2 practical boosts: synonym mapping and fuzzy trigrams. You will get working intuition and a small reusable pattern for more advanced search. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Cosine similarity is our core metric. It measures how much 2 texts point in the same direction after we convert them to vectors. So it optimizes relevance by overlap rather than raw length. The main trade-off is simplicity for semantics. It is fast and explainable, but exact word overlap may miss paraphrases unless you add synonyms or fuzzy matching. Practically, this approach works great for hundreds of FAQs and for low latency responses in interactive systems. The idea is simple. Turn text into small token sets, compute a normalized overlap score, and pick the highest scoring answer. It shines on short queries and tight FAQ collections. Its limitation is that raw token overlap misses deeper semantics, which we will address with a tiny synonym map and character trigrams. Next, we will tokenize a minimal query and show what the system considers as words. This snippet tokenizes a short FAQ query into clean lowercase words. It defines a tiny query variable named q and a regex-based function talk that extracts only letters and digits, ignoring punctuation and casing, so words like return and return become identical. Lower casing is what makes later matching consistent. The function returns a plain list of tokens that downstream steps treat as the fundamental units of meaning. The printed list demonstrates exactly which tokens the search will compare against the FAQ entries, so you can see what counts as a match. Now we'll score a single FAQ against a query using overlap and length normalization. This snippet computes cosine similarity between one query and one FAQ using token sets rather than numeric vectors. It runs the token function to turn both strings into sets of words. So presence or absence of a word becomes the signal. The intersection size is used as the dot product, and the square roots of each set size act like vector lengths to normalize the score. Dividing the overlap by the geometric mean keeps scores between 0 and 1, so higher means more similar, independent of document length. The number printed shows how well that single FAQ matches the query. Next, we'll rank a small list of FAQs and pick the best match. This snippet ranks 3 FAQ answers and returns the best candidate by comparing cosine scores. It sets up a compact list of documents and uses the helper cosine routine that computes binary cosine from set overlap and length normalization. The token function produces sets for the query and for each document, and the code scans all FAQs to find which one has the highest normalized overlap. The result printed is the top-ranked FAQ answer candidate, which demonstrates the core behavior of a basic search. Compute relevance, then choose the maximum. Now let's add a simple semantic boost with a synonym map before comparing tokens. This snippet applies a tiny synonym map to the query tokens to increase semantic overlap with the FAQs. The variable QS remaps a token like period to policy so that a query using a shorthand can match the wording inside the return policy answer. The code computes cosine scores using the remapped token set and still normalizes by vector lengths, so scores remain comparable. Using a dictionary lookup inside the token mapping is a compact way to handle synonyms without external libraries. You can add more pairs to the mapping to improve coverage, and the printed score reveals how much the synonym helped. Finally, we'll try fuzzy matching with character trigrams to catch typos and partial word overlaps. This snippet ranks FAQs using character trigrams for a more forgiving similarity. It removes spaces and builds sets of 3 character chunks with a helper function g, so that partial overlaps like pass and password still register as shared features. Cosine similarity is computed on those trigram sets, which handles typos and word form variations better than plain word tokens. The max operation picks the best matching document under this fuzzy scheme. Note that increasing the gram size makes matches stricter and decreases false positives, while decreasing it loosens matching but may add noise. Recap: this is a lightweight FAQ search that ranks answers by cosine similarity on token sets. Use it when you have short queries and a compact FAQ collection and want fast, interpretable results. One caveat: token overlap is not the same as true semantic understanding, so synonyms and fuzzy brams matter. Next step: tune the trigram size or experiment with adding term weighting, so you can trade sensitivity for precision and measure the difference on a holdout set. If short practical IR helps your project, subscribe and watch the rest of the search and information retrieval videos.